What up, Shaq here. And today the topic we're going to be covering is finding the nth term of an arithmetic sequence. Before we look at the concept of nth term, let's discuss what an arithmetic sequence is. And we have a definition right here. An arithmetic sequence is a sequence where the difference between successive numbers is a constant. That means added or subtracted by the same amount. So let me show you an example of an arithmetic sequence. 3, 6, 9, 12. Because we're adding by 3 every single time. Let me give you an example of another arithmetic sequence. 8, 6, 4, 2. Because we are subtracting 2 every time. Let me give you an example of a sequence which is not arithmetic. 3, 6, 12, 24. Because the sequences here is where we're multiplying by 2. This is not arithmetic because you have to be adding or subtracting by the same amount, not multiplying. This sequence is an example of a geometric sequence. Alright, but today we're going to focus on arithmetic sequences only, okay? Now, what does finding the nth term mean? Well, I think it's best explained by showing an example. Here we have a sequence. 2, 5, 8, 11. First of all, we can recognize it's arithmetic because we're adding 3 every time. And imagine someone says, all right, here's a sequence. You have the first 4 numbers in the sequence. Find the 100th number in the sequence. So a common thing people would do is just go, okay, we have the 4th term. The 5th term is 14. The 6th term is 17. The 7th term is 20. The 8th term is 23. The 9th term is 26. And we're going to keep on going till we find the 100th number. But our problem with that, guys, it'll take way too long. It'll take us like an hour. We're going to have to keep on adding by 3 until we get to the 100th number, which is a total waste of time. Instead, what we can do is we can find the nth term to help us, okay? And once we find the nth term, we can pretty much find any term in this sequence, okay? And there's 2 methods on finding the nth term. The first way is called the table method, and let me show you how that works. What we're going to do is we're going to draw a little table. On the top will be n, and the bottom will be t. N stands for the order of terms. T stands for the term. So basically, the first term is 2, the second term is 5, the third term is 8, the 4th term is 11. Okay? So you start by creating a table, okay? Step 1 is, what's the jump every single time, guys, in this sequence? It is plus 3, plus 3, plus 3. If it's plus 3, you have to write 3n, okay? If it's plus 4, you'll write 4n. If it's plus 5, you'll write 5n. But here, we're adding 3 every time. So we're going to do 3 times by n, okay? That's our first step. Step 2 is we're going to multiply 3 by our n values, okay? So 3 times 1 makes 3. 3 times 2 makes 6. 3 times 3 makes 9. 3 times 4 makes 12. Okay? Now, we compare our numbers. How do we get from 3 to 2? How do we get from 6 to 5? How do we get from 9 to 8? And how do we get from 12 to 11? Well, for every single one of them, we subtract 1. Subtract 1. Subtract 1 and subtract 1. Therefore, our final formula is 3n subtract 1. We get the 3n from here and the subtract 1 from here, okay? And 3n minus 1 will give us our term we're looking for, okay? So that's our nth term. 3n minus 1 will equal to our term. Now, someone's like, okay, dude, what's the 13th term in the sequence? All we're going to do here is I'm going to write down So I'm going to replace n with 13 because I'm trying to find the 13th number in the sequence. So it's going to be 3 times 13 minus 1. And that's going to be 39, 38. The 13th term, the 13th number in the sequence will be 38. Now what happens if someone says, yo, what's the 100th term in the sequence? What we're going to do is we're going to replace this n with 100. So instead of 3 times n, we'll do 3 times 100. And that will give us 299. So if we're looking for the 100th term in the sequence, it'll be 299, okay? So that's the first way of doing the nth term, is making a table, okay? We have a second way. It's the more technical way. It's called the a plus n. Oh, I made a mistake. It's called the a plus n minus 1 d method, okay? Now, all we have to do in this method is to understand what each of these letters means. A stands for the first term. And D just stands for the difference between terms, okay? So all we do, difference between terms. All we're going to do is we're going to plug our numbers in from our sequence. So we'll use the same sequence. 2, 5, 8, 11. So A is our first term. Well, our first term is 2. So A is going to be 2. So 2 plus n minus 1 stays the same. N minus 1. D. D is the difference between terms. Well, the difference between terms is 3. We're adding 3 every time. So it's going to be 3. Then n minus 1, 3 means n minus 1 multiplied by 3. So we're going to expand those brackets. So it's going to be 2 plus 3 times n makes 3n. And 3 times minus 1 makes minus 3. Then we're going to simplify these terms. So we can do 2 minus 3 makes minus 1. So it's 3n minus 1. And that's going to be our nth term. And then it's exactly what we got in our last method, okay? 3n minus 1. So those are two methods you can use to find the nth term, okay? So feel free to use whatever method suits you better, all right? And now we're going to work on some practice problems. All right, guys, let's look at some common past paper questions, all right? So here are the first 5 terms of a number sequence. 7, 10, 13, 16, 19. Find the 10th term in this sequence. Well, let's have a look. So far we have the first 5 terms. First term, second term, third term, fourth term, fifth term. And I notice we're adding 3 every single time. So it's an arithmetic sequence. So let's just keep adding 3 until we get to the 10th term. So the 6th term is 22. The 7th term is 25. The 8th term is 28. The 9th term is 31. And the 10th number of the sequence is 34. And that's our answer. Next one. Write an expression in terms of n for the nth term of this number sequence. So the nth term means the formula. So let's use our 2 different methods to find the nth term, okay? So the first method will be the table method. So I'm going to draw a table. N and T, and we're going to fill it out. The first term is 7. The second term is 10. The third term is 13. The fourth term is 16. You don't have to do all the terms. I'm just doing the first 4 numbers in the sequence. So step 1, what's the jump every single time? It's plus 3. Therefore, it's going to be 3n. So 3 times by n. Step 2, we're going to multiply 3 by our n values. So 3 times 1 makes 3. 3 times 2 makes 6. 3 times 3 makes 9. 3 times 4 makes 12. All right? Now, what do we notice about the difference between these numbers? From 3 to 7, 6 to 10, 9 to 13, 12 to 16. We're adding 4. So it's going to be 3n add 4. That's our nth term, is equal to our term. All right? Let's use our second method. A plus n minus 1 d method. So we have our sequence. So a is our first term. Well, the first term in the sequence is 7 plus n minus 1. D is the difference between the terms. Well, we're adding 3 every single time, so it'll be positive 3. All right, let's expand the brackets. So it'll be 7 plus n minus 1. 3 means n minus 1 multiplied by 3. So n times 3 is 3n. 3 times negative 1 is negative 3. Let's combine the terms. 7 minus 3 is positive 4. So it's going to be 3n positive 4 will give us our term. And great, our answers are matching, okay? So yeah, it's 3n plus 4 is equal to our term. So feel free to choose whatever method you want to use, okay? You don't have to use both. Finally, I've added on this extra question. Find the 100th term in the sequence. So we have our sequence. Let's draw our table out to help us visualize. So the first term is 7. The second term is 10. The third term is 13. The fourth term is 16. We want to find the 100th number in the sequence, okay? Well, I don't want to keep on adding by 3 until I reach the 100th number. Let's just plug 100 into our nth term. So we have 3n plus 4 is equal to our term. We're going to replace n with 100 because we're looking for the 100th term. So 3 times 100 plus 4, which is equal to 304. So the 100th number in the sequence will be 304. All right. Right, homies, question 2. A number sequence has nth term 6n plus 3. Write down the first 4 terms in this sequence. All right then, let's draw our table out. N and T. N, remember, stands for the order of terms. T stands for the term. So we're trying to find the first, second, third, and fourth terms, okay? So how do we do this? Super simple. Our nth term is 6n plus 3. All we're going to do is replace, if we're looking for the first term, we're going to replace n with 1. So 6 times, instead of n, 6 times 1 plus 3 equals 9. So the first term is 9. To find the second term, we're going to replace n with 2. So 6 times 2 plus 3 equals 15. To find the third term, we're going to replace n with 3. So 6 times 3 plus 3 equals 21. And to find the fourth term, we're going to replace n with 4. So 6 times 4 plus 3 equals 27. So someone said, so those are our answers, 9, 15, 21, 27. So someone said, yo, what's the 100th number in the sequence? What we're going to do is replace n with, you guessed it, 100. That was the question. 603. All right, so those are the first 3 marks. Pretty straightforward, guys. Next, Sarah says that 1008 is a term in this sequence. Explain why she is wrong. All right, what do you notice, guys? Let's look at our terms so far. The first term is 9, second is 15, 21, 27. Do you notice something in common between all these terms? Yeah, they're all odd. All the terms are odd. But 1008 is an even number. So, therefore, 1008 cannot fit in this sequence because the only numbers in the sequence can be odd numbers, okay? So, sequence provides odd terms, but 1008 is even. Alright, that's the first way of explaining, okay? There is a second way of explaining this. A bit more technical way. Let's draw our table again. N and T. Let's fill out our table. So the first term is 9, the second term is 15, the third term is 21, The fourth term is 27. All right, let's check. Let's double check if 1008 is a term in our sequence. All right, and if so, which term is it? So what we do is we get our nth term. And to check if a number is in a sequence, you equal the term to 1008. You do not replace n with 1008. So we're going to get our nth term, and we're going to set it equal to the number we're checking, if that's a number is in the sequence. And we're just going to solve for n, and so work backwards, okay? So minus 3 on both sides. 6n equals 1005. And then n's being multiplied by 6. To get rid of multiplied by 6, you divide by 6. So that cancels out. N is equal to 1005 divided by 6. 167.5. So 1008 is the 167.5th term. Is it possible to have a 167.5th term? Can we have a decimal term? We can have a first term. We can have a second term. What's the 1.5th term? Is that possible? No. We cannot have a decimal term. So what we can say is this. 1008 is the 167.5th term. You can't have a decimal term. And it's another answer you could have provided to get that 1 mark. But probably pretty easy. You just recognize that all the numbers in our sequence were all odd. 1008 is even, so it won't fit. All right, let's move on, guys. Next question. Martin has written the first 50 terms of the sequence with nth term 150 minus 4n. Work out which term is the first negative term. All right, let's try and understand this problem. So we have a sequence. I draw my table, n and t. And our nth term is 150 minus 4n. Let's first start by trying to fill out a few terms in this sequence. Let's find the first term. So what I'm going to do is I'm going to replace n with 1. So 4 times 1. 150 times 4 times 1 makes 146. Let's find the second term. I'm going to replace n this time with 2. So minus 4 times 2. 4 times 2 is 8. 150 minus 8 is 142. Let's find the third term. So 150 minus 4 times 3. 4 times 3 is 12. 150 minus 12 makes 138. And basically we have to keep going, guys, until we find the first term, which is negative, or the first term which is less than 0. Right now, which term gives us a term which is less than 0? So, how do we do this, guys? Well, what I like to do in this problem is basically find out which term gives me exactly 0. So, we need to check which term gives me a value of 0. Now, how do we check if a number is in a sequence? Well, we set the nth term equal to the number we're checking. So we're checking for 0. We're trying to find out which term gives us 0. And let's go ahead and solve it slowly. So let's solve for n now. So first, we're going to subtract 150 from both sides. So it's going to be minus 4n is equal to negative 150. Then n is being multiplied by minus 4. Opposite of multiplying by minus 4 is dividing by minus 4. That cancels out. So n is equal to negative 150 divided by negative 4 is 37.5. So basically, the 37.5th term gives us a value of 0. All right. So first of all, we can't really have a 37.5th term. But if we did have a 37.5th term, it would be 0. Therefore, which term will give us a value of less than 0? It'll just clearly be the next term. So what's the next whole number after 37.5? It's the 38th term. The 38th term should give us a value, should give us a term of less than 0. Let's check. So to find out which term the 38th term is, we're going to replace n with 38. What does that make? 150 minus 4 multiplied by 38 gives us -2. Yep, and that is going to be the first negative term, -2. So what we did there, guys, was since we're trying to find the first term which is negative, or the first term which is less than 0, we're going to find which term it gives us exactly 0. Alright, and we do that by setting our nth term equal to 0. And 0 is basically the 37.5th term. Therefore, the next term after that, the 38th term, must be the first negative term. And the 38th term is -2 after we replace 38 into n. Alright guys, final question. Let's have a read through. The 7th term in an arithmetic sequence is 20 and the 11th term is 44. What is the nth term? Alright, so let's start off by drawing a table to understand this problem. Well, we know the 7th term in the sequence is 20, and we know the 11th term is 44. We don't know what the first term is, nor the second, nor the third, nor the fourth, nor the fifth, nor the sixth, 8th, 9th, 10th. This is all we know, guys. We only know what the 7th term is and the 11th term is. So, the key to this problem, guys, is realizing that this is an arithmetic sequence. And if we go back to the beginning, an arithmetic sequence is a sequence where the difference between each successive term is a constant. Okay, so that means the jump from the 7th to the 8th term is exactly the same as the jump from the 8th to the 9th term, which is exactly the same as the jump from the 9th to the 10th term, and from the 10th to the 11th term. So, let's draw an arrow from the 7th term to the 8th term. Let's call this jump from the 7th to the 8th term x, plus x. Therefore, since it's in an arithmetic sequence, the jump from the 8th to the 9th term will be x as well. And 9th to 10th will be x. And 10th to 11th will be plus x. Okay. So look, we made a little equation, guys. We've got 20 plus 4x makes 44. So 20 plus 4x makes 44. All right. Let's solve this equation real quick. So that's minus 20 on both sides. So let's solve for x to find our jump. So we're going to minus 20 on both sides. So now we have just 4x is equal to 24. Now x is being multiplied by 4, so we're going to divide by 4 on both sides. So x is equal to 24 divided by 4 is 6. So the jump between each term is 6. And let's check. 20 plus 6 is 26. 26 plus 6 is 32. 32 plus 6 is 38. 38 plus 6 is 44. Very nice. All right, now we got to find the nth term. So let's think back to the beginning. How do we find the nth term in the sequence using our table method? Well, step 1 is if the jump is plus 6 every single time, it's going to be 6n. Step 2 is we're going to multiply 6 by the n's, the terms that we know. So we're going to multiply 6 times by 7, which makes 42, and 6 by 11, which makes 66. Now, how do we get from 42 to 20, and how do we get from 66 to 44? Yeah, for each of those, we subtract 22. So therefore, our nth term is 6n minus 22. And that's our answer, guys. And we're all set for this topic.